Welcome back, fifth graders. Today what we're going to be focusing on is using letters to identify geometric figures. Something to change up in my video and channel. Every video I'll be calling out one or two students for inspiration or even just drawing sticks towards the video. Okay, the people I'll be calling out today are the inspiration of the call-outs. So maybe you know who you are, but we'll cover that at the end of the video. All right, so stay tuned for that. If you have questions on lesson 61, hopefully I'm able to answer them. If not, don't be afraid to email me. I'm always by my email, so don't be afraid to email me at any time. Okay, so using letters to identify geometric figures. In geometry, we often use letters to refer to points. We can identify polygons by the points at each vertex, or each point where two lines meet. Okay, so for example, this triangle, of course, has three different points. Okay, we could classify this triangle in many different ways. We could call this triangle A, B, and C. Okay, because we go A, B, and C. We could also call this triangle A, C, B. A, C, B. Now we don't go back, we don't say A, B, C, A. A, B, C, A. We don't do that. Okay? Once we have named all the points that we can, that's it. We don't say it twice. Okay? We also could classify this triangle starting with B, BAC, or triangle BCA. BCA. Another way we could classify this triangle, there are two more ways. We could start with C, the vertex at C. We could go CAB, or we could go CBA. CBA. Okay? Now, notice how I drew a triangle at the beginning. That classifies it as a triangle. Okay, so instead of writing out triangle, like the word triangle, and I know how you guys are all about the abbreviations, this is your abbreviation for triangle when you're dealing with vertexes and different points to classify a triangle. Okay, we don't just write out triangle, we put the symbol instead. Okay, now we have a square. Okay, so to classify the square, we would write square. We could start with D, C, B, A. Okay, we could classify it as that. Okay, we could also classify it as D, A, B, C. D, A, B, C. What we couldn't do is we could not do this. We could not classify it as D, B, A, C. You cannot, since there's no line connecting D and B, you can't just jump straight across. Okay, you have to find a line segment or point that connects to the starting point. So I started at D. The only two options I could choose from are A and C. So again, you could go D, A, but you can't go across to C because no line or segment connects A and C together. So you can't do that. So you can't do this and you can't do this. Okay, the segments have to be connected to each other. So watch out for that. But your starting point doesn't matter. You could say this square is A, B, C, D. Absolutely can say that. Okay, just don't connect two segments or points that aren't connected by a segment. Okay? Alright, so when we have different figures, okay, so in this first row here, we have a line. Now remember, a line has two arrows at the end, okay? We would classify this line as line AB, and instead of writing line, we would write it as AB and then with a line above AB, if that makes sense, just like it shows up on the board. All right? A segment, remember, has two dots or two endpoints at the end of the segment. Okay? Or it could just be a line, just like that. That's a segment right there. Okay? It has two endpoints. It doesn't continue on infinitely. It just stops wherever the lines stop. Okay? We would classify this segment as segment AB because that's the 2 points that are on that segment. And then we would abbreviate it with just a segment over whatever 2 points or however many points there are on that figure. All right, and then the last one is array. Now remember, array has a starting point, so it has a set point, and then it continues on infinitely. So it has a solid point here, then your segment, and then it ends in an arrow. That's array. Okay? We would classify this figure as ray AB because it's array, and that's the 2 points that are on the array. All right? And then to show that it's array, the abbreviation would be AB, and then just draw array above the 2 points, okay, of the abbreviation. All right? Just give you a lowdown on some abbreviating that we can do. Okay, we may name an angle using the single letter at its vertex if there is no chance for confusion. Okay, so for example, all right, let's find the two. Let's find the points that have. Let's find a point that has an obtuse angle. Okay, now remember, an obtuse angle is when it is more than 90 degrees. So remember, you have your hands 90 degrees. It has to be open more than 90 degrees. So the point or the angle that has, or vertex that has 90 degrees would be D. Or we could go angle ADC, because that's a little more than 90 degrees. So then to write that, we would write angle, since this is an angle, ADC. That would be for an obtuse angle. Okay, how about an acute angle? So let's erase this. Let's find an acute angle. Let's go here. Remember, an acute is less than 90 degrees. Okay, so there's our acute angle. So that would be angle C, D, and E. Okay, that's the correct way of writing that out. Okay, now there's a lot of different, you could have went angle BAD for an acute angle, less than 90 degrees. Okay, there's no right angles in this one, so that helps a little bit. All right. This would be array, technically. If we have here, we could go ADE. So it would be ADE, and then if we want to label it array, we would draw array above that. Okay, because it starts with a single point. Now we add D into it because that point is found on the array. So you can't just go A to E. Okay, you have to put A, D, E. Okay, and then you put array above it. All right. Example 1. In rectangle ABCD, name the segments perpendicular to AB. Okay, so that's the first part of the question. Here's AB, line A, or segment AB. Name the segments perpendicular. Now remember, perpendicular are lines that run into each other. Okay, so what two lines run into AB? Okay, we could do this line runs into AB, and that's segment DA, and this line runs into AB, so that would be segment CB. Now, we could have labeled it as also AD or segment BC. That would work as well. Okay? Second part of the question. Name the parallel segments in the rectangle. Okay? So so now we're just naming the parallel segments that are parallel to each other. Okay? Now remember, parallel are segments or lines that never cross. Okay? They never run into each other. So let's stay with segment AB. Okay? What segment, so here's AB, what segment is parallel to AB? It would be DC. Segment DC. Alright? And then what's the other parallel segments that are in this rectangle? I would say this segment and this segment. Okay, so that would be segment DA and segment CB. Okay, so that would be your answer for the second part, for the parallel. Alright, example 2. The length of segment PQ is 3 centimeters. So let's write that down. PQ is 3 centimeters. The length of segment PR is 8 centimeters. So P all the way to R is 8 centimeters. What is the length of segment QR? So then we're trying to find this right here. We don't know what that is. Oh, I'm putting a 3 there. We don't know what that is. Okay, we know it's centimeters, but we don't know how far it is. How can we figure out how far QR is? We can subtract, correct. Okay, so we could go 8. Since the total amount was 8, one segment was 3, it would be 5 centimeters. So QR that would be segment QR would be line QR, nope, yeah, it would be segment, excuse me. Would equal 5 centimeters. Okay? And then last example. In quadrilateral QRST, angles S is an acute angle. Name another acute angle in the polygon. So angle S would be right here. That's an acute angle. We need to find another acute angle. Which one would be an acute angle? I would say the one that's opposite of it. I would say angle Q. Now remember, you have to label it with a symbol. Don't put the word in front of it. Okay? Don't use symbols, abbreviate when you're dealing with that. Alright? That is lesson 61 for you guys. This shout out video goes to Gabri and Ava. They make their own YouTube video. They've shouted out this math class before. If you haven't seen them on YouTube before, go subscribe to their page, go like some of their videos. I know they'd appreciate it. Some good and funny ones that we've seen in class here, usually on Fridays. So keep making videos, ladies, and hopefully you guys subscribe to this video, like it, let your classmates know that this is out. Let them know if you have questions to email me. All right? Miss you guys. Hope to see you soon. Peace.